Hello again, and welcome to my next session, which is the Enterprise Mobility Services Overview. I'm JT, Senior Director of Application Developer Products, and I'm responsible for all the developer product management and product marketing here at Embarcadero. You can contact me at jt@embarcadero.com. Twitter handle is @FireMonkeyPM, and there is my blog URL. So in this session, we're going to basically get into enterprise mobility services. What was the motivation behind it? What were the challenges enterprises are facing that drove the requirements and features of enterprise mobility services? Then we'll dig into what those features are and from an architectural perspective, and also what each of the individual features do. And then we'll do a demo and we'll take some questions. So let's jump right into it. So as we talk to enterprises and analysts and try to understand a bit more about the types of challenges enterprises specifically are experiencing when they try to mobilize, there was some pretty consistent challenges that they all faced. And basically these are the key ones that we focused on resolving or addressing in this first version of Enterprise Mobility Services. The first is that enterprises need to securely access data from back-end databases kept behind their firewall that they manage, that has their intellectual property living in it. They need to be able to securely move that to a mobile device and keep that information secure on that device. So security was pretty important, but so was getting this data from behind their firewall. The other thing that they've told us is a big initiative is exposing custom APIs. And this is both for their own developers as well as third-party developers. So this was a pretty consistent trend in order to build new apps or to expose infrastructure and services to other developers and applications. They're exposing them through custom APIs through standard REST. The third thing that we heard is that they have all sorts of different databases. So they need access to all these major databases like Oracle or Sybase, Informix, SQL Server, so on and so forth. They need high performance access to these, and they need broad support for a number of these. And the final thing that we heard was they need to be able to analyze how their services are being used by users. So understanding which services are being used most, how often they're being used, by how many users. These types of analytics were critical in understanding who's getting into the system, who has access to these services, and finally, how they're being used. So given those requirements and challenges, we've built enterprise mobility services. And there was an additional feature, if you will, that we wanted to provide, which was we wanted to make it really easy for a development team to be able to build this type of service and deploy it into their enterprise. Now, of course, you do need IT help at some point once you're ready to go public with your service, deploying it into production. But by and large, we wanted developers to be able to build, develop, test, and then easily pass on something to IT that could then be taken into production. And we call this a turnkey middleware server. In other words, all the pieces are there to make it easy to build and deploy these existing services. So some of the services that we provided to help address these challenges include user management and authentication. So being able to know who has access, authorizing them access both by username and by group level, and then being able to use that information later on in analytics. So that user management was a pretty important piece. The other piece, and this was related to custom APIs, was being able to load modules or add new modules easily without affecting the production server, and basically to deliver custom APIs via the REST protocol. We also deliver our enterprise SQL data access technology, FireDAC, to access all these major databases, but then we provide an additional mechanism to access that data through REST APIs. So this is similar, if you use DataSnap, similar to how DataSnap publishes data through its middleware. EMS does the same using standard REST APIs. And then lastly, we needed to address the secure data storage issue. And so EMS includes licenses for our mobile embedded interface to go products, as well as SQL or server-side SQL data storage and interface server. Now, EMS itself is run by an interface server, as is access to a full interface server for the number of users that are licensed. But we also, again, provide those drivers for all the other major databases. And the final feature that we've introduced and service for that matter, is a console for analytics, being able to see who the users are, which devices they're using, and which APIs they're calling. So let's take a closer look at how this looks. EMS itself is made up of plugins, pluggable modules that you write in Delphi or C++ Builder, and you deploy into an IaaS server instance. Additionally, you deploy along with it the Enterprise Mobility Services database, which is powered by Interbase. So the combination of those two things, at least one module and the Enterprise database, is an EMS middleware server. If you want to add more custom APIs, if you want to add more data access, then you would create new modules that can be deployed into a live production system to enable access to those APIs. And then you use the user management facilities within the database to say who has access to these resources, and either at the username level or at the group level. So the EMS database is also what powers the EMS console. When the console goes in and says, okay, what users are connected to the database, who's accessing which REST API calls, it's querying that EMS database for that information. So that's the turnkey part of delivering an EMS server. On the back-end side, you have your FireDAC drivers that you use then to connect to your major SQL database or your Interbase server. And you can also integrate cloud services in the middleware layer. These can be integrated pretty much at any tier, whether it's the client itself or here in the middle tier. But this is an optional way to connect into backend as a service providers, for instance, to do push notification through the middleware itself and not at the client. But speaking of the clients, this is the other part of EMS, which includes the Interbase to Go database, the secure embedded database. And using the REST APIs and using the backend as a service components, you access these middleware services through EMS. So today, I'm going to demonstrate, for example, creating a REST service that doesn't require logging in. So I just use the basic REST client for that. But Marco and Jim in later sessions are going to talk about using the EMS provider or backend provider components to be able to do the user authentication and management, as well as the data access through with the user rights. So this is the basic overview and layout of what is EMS. To dig a little more into the user authentication analytics, user authentication again is managed a lot like most authentication systems, where you have a set of users, and users belong to groups, and those groups have certain rights, read or write or execute rights for a given resource. It's a lot like if you're familiar with the Linux file system, using ChangeMod, for example, to be able to set rights on a user, group, or other level. So it's a very similar concept in terms of user management. The authentication then can happen through password or through connecting into some other type of directory service. Then with the analytics, this will show you when calls were made into the service, which service it was, which API call, which users were accessing that service. And you can do this over any length of time that you'd like, or as granular as you'd like, to really understand the usage of that particular resource. So that kind of lays the groundwork for what EMS is. Let me give you a quick example, a quick demo of how this works. I'm going to create a basic REST service, creating an EMS module. This is going to be a standalone server, so I'm not going to deploy it into IIS, but rather in a standalone executable. Then I'll create a client that makes a REST call using the low-level REST components. And like I say, in the follow-up sessions, you'll see how to use the backend provider to do your user authentication to get access to that resource as well.
Okay, so what we're going to do is we're going to do a new other EMS package. So the package is how you basically build a unit. Now, from here, this is going to build the standalone server version. It can create an empty package, or I can create one with a resource. So I'm going to choose a resource because I want to create a get a resource that I'm going to add a REST API on top of. So I'm going to name that resource. I'm going to do a simple reverse string example. So a string will be passed to me, to my service, and the service will reverse it and send back that reversed string. And I'm going to do get requests only for this endpoint. And of course, you have support for pretty much all the standard endpoint type of requests. So let's look at the code that was generated for the get and get item. So the reason why I'm going to use get item is because it already fills up the parameters that I'm going to be receiving into a handy L item that I can work with. So that L item, what I'm expecting somebody to send me is a single string that I will then reverse. So the way that I send it back is I use this response object right here, and I create a JSON data packet that can be sent back to it. And it's a lot simpler than it sounds. So let's just show you a line of code that does this. I'm going to use that response object. And in the body of that object, I'm going to set a value. And this value needs to be a tJSON value and a Boolean. So we're going to create a tJSON string. And let's just finish the second parameter here. This gives ownership in terms of automatic reference counting. And in here, I want to take the string that was passed in, which is going to be stored in this L item, and I want to reverse it. So I'm just going to call an API function called reverse string and give it the L item. And it looks like I forgot to add my uses clause for that reverse string function. Okay, so that's really all that's required to get an API up and running, a get API up and running that takes parameters. So let's go ahead and run this server, and I'm going to run it on 132 here, and it is on port 8080. This calls a created endpoint called version that you can call anytime to know which version is being run. But let's go ahead and call the API that I just created. So the way that REST works is each of these endpoints represent a URL off of some base directory. And the name of that endpoint is the function name. So in this case, if I just call reverse string and don't pass it anything, I get nothing back. And now I pass the parameter as the next element in this URI. So since David I is here, we're going to reverse his name. And you see that what happened was the call went back to my REST resource and sent me back a JSON data packet that was a reverse string. You can also see that the calls are being logged here in this log. This is information that will be stored in the database that we'll later use for analytics, and Marco will go into the details on the analytics on Tuesday as well. So how do we create a client now that can talk to this? So let's go ahead and create a new application. Okay, so here we have a basic Windows client, and since we're going to make a REST request, I'm going to grab a REST client. And the first thing we're going to do is we're going to set it up to point to my server, which is the base URL property. And this one is running on localhost, port 8080. Now we need to make a request. So let's grab the REST request. And while we're at it, let's grab the response too. Because these two are intimately connected. So in my request, this is where I'm going to plug in that resource. So that resource name was reverse string. And for sake of demonstration, I'm going to go ahead and just add the argument right here in this resource so that we can execute the call right here in the designer. So it made a request and it was successful. Now we can look at the response, which gets that JSON data packet, and see that I got back that information that I was expecting, my reverse string. So now let's make this dynamic. We'll take a string in an edit control, and in an on button event, we will send that string over to the REST service and ask it to be reversed. So we'll take the REST request, and we will tell it we want to go to this resource, and we'll give it the name of the resource again, which is reverse string. Don't forget the / plus whatever's in my edit1 control. Okay, and now we're going to execute that request. Now you see there's async executions as well. This is what you would normally use, but for the sake of demonstration, I'm going to use a synchronous execute so that I'll get a value back that we can show, because we want that information in the REST response for a show message. There we go. That should do it. So let's make sure this works now and runs. Okay, we'll put David I's name in there again. And voila. So if we go back and look at the console, we'll see that that was also called there again. Reverse string was called right at this time.
Okay, so now that you've seen it in action, let me tell you a little bit about how EMS compares to DataSnap. DataSnap has been the middleware or end-tier solution in Delphi and C++ Builder for many years. DataSnap is really should be seen as like an SDK. You can build everything you've seen here with DataSnap, but you build it yourself. It's an SDK with the parts to build these types of services. So you build your own server. You can create REST versions of it or even SOAP versions. You can also use FireDAC, but again, you're building these services. So for example, the user management is something that you would need to build. The analytics is something that you would need to build separately, but the parts are there for you to do it inside the DataSnap SDK. EMS, on the other hand, as we talked about, is a turnkey ready-to-use solution. You saw how easy it was for me to create a new resource, deploy it, and connect into it. And that's about basically the approach you just saw was creating server extensions, which exposes these REST APIs or data access through FireDAC via these standard REST APIs. So EMS uses a standard REST in JSON, which means it's fully stateless. There's no sessions, and that means that it's also more scalable and more robust because there's no session management that could cause issues. On the DataSnap side, there is session management. This is just the way DataSnap has been built over the years. Even if you're using REST, there's some session management. Now you do have options to not use sessions, but this is generally how the architecture was designed to be used. So that's a pretty big difference between the two of them. EMS includes the user management, the API call analytics, and the console. Again, DataSnap, these are things that you would have to build on your own. And similarly, they both are self-hosted solutions. In other words, neither of these are living on the cloud that we, Embarcadero, provide a service for you to subscribe to. Rather, you deploy it on premise or within your private cloud to integrate it into your existing systems. And so I guess the last difference that's worth mentioning is DataSnap is part of Enterprise or above. It is part of that license, so it's free deployment, but it's only included in the Enterprise SKUs and above. EMS is an alternative that is free to develop, but you pay per user for these additional services. But remember that it does include Interbase Server and Interbase To Go. So these are traditionally user-based licenses that are now part of this subscription to deliver these services, including all the things that you saw with analytics, but also the secure interface embedded to go and the interface server. So just to kind of close and help you see the overview of EMS again, we're talking about a couple key component pieces: the ability to build these plugin packages that get deployed along with the EMS database, that drives the EMS console, the FireDAC drivers on the back end to talk to all the major databases, the included interbase server license for the number of users that you use, the included interbase to go license for your users as well, and then the accessibility through REST APIs or through the backend provider components. So this was just a really basic overview today. I barely scratched the surface. Highly recommend either one of these sessions in the C++ or Object Pascal track, where Marco is going to talk about working with SQL databases at different times tomorrow. And Jim is going to talk about authentication and authorization at different times tomorrow as well, depending on which track you're in. So if you attend these 3 sessions, you'll have a pretty good understanding of how EMS works and how you can use it within enterprise to deliver these sets of services quickly and easily. Okay, so at this point, I'm ready to take some questions.
How do I get a hold of EMS? Is it part of XE7 or is it separate?
EMS is part of XE7. If you go back into the video, what you see in it needs to be a pro client server or above. So that includes enterprise, architect, ultimate, etc. You'll see a new project type called or folder called EMS. So where you go into the file menu to create a new project, you'll want to go into other, which will load up the gallery. And in the gallery, you'll see an EMS folder. And in the EMS folder, you'll see the ability to create the module. So each one, you create a module for each resource that you want to make available, whether that's data access module or a custom API REST module. So you get basically one endpoint or a set of endpoints per module, a get, a put, those kinds of inserts, those kinds of web endpoints. So you get one set of those for each module. And then you can build it in Delphi or C++ Builder, generate a standalone server, and then you're ready to go. So you have everything you need in the product today to start developing with it, including interbase to go test licenses and the interbase server 5 user license. So all the component pieces are there. And then when you're ready to go to production, you can contact our sales department to get access to the ISAPI module and start figuring out what kind of capacity you're going to need in production. In other words, the number of users you're going to need to support.
Okay, great. Yeah, actually, one of our MVPs was experimenting with EMS, and he's like, I'm not finding this. And I pointed him in the right direction. He's like, oh, wow. And he's like, oh, this is so easy. This is so cool. He was really excited about it.
Yeah, we really wanted to make it as easy as possible to get all these standard services that are, pretty necessary now, including things like analytics.
Yep.
And the most important thing, the reason why we did EMS was to make a fully REST standard solution that's fully stateless. That means you can also write clients in other languages, et cetera, because it's just standard REST endpoints that you're working with.
Yeah. So Keith says EMS is a dream come true. Are there any metrics available for it?
I'm assuming you mean performance metrics. We will work on publishing some. In general, you will tend to get better performance because you don't need to manage sessions, and it's also going to be more scalable for load balancing, et cetera, again, because of the lack of no requirement for session management. But we haven't published any yet, but that's something that we can look to do in the near future. Of course, with that said, do not measure the standalone server. You're going to want to measure against the ISAPI module because that's going to be the most performant.
Yeah, that'll make a huge difference in performance.
Yep.
Can the data payload be something other than JSON, or is JSON inherently the expected way within EMS to serialize data?
It's JSON. But you can do all sorts of things with JSON that may not seem obvious. I mean, it looks on the outset like a bunch of tuples or key value pairs, but you can encode information in there. You can move binary files it's a pretty complete format and a simple format to use as well.
Right. So I guess if you're really opposed to JSON, you could just input codes in binary and throw it in there. And
yeah. And that's, again, if you want to use the REST JSON framework. I mean, there's certainly, you can, at any point, if you want, open up a socket and use socket connections if you need to. So it doesn't mean you can't use other technologies. It's just that the technologies, the way that we present it is through standard REST and JSON. And you can always shell out to some other type of connection that you may need depending on your application.
So a couple of people saying, how does this compare to X, Y, whatever? What's the difference between this and some other third-party offerings that are out there for JSON, data, putting data and such?
Well, I guess the main way that it differs is that it's a turnkey solution. REST and JSON are really just the implementation technologies, but what's really powerful about this is the modular approach in which you can develop with Object Pascal or C++ on the back end to create those custom APIs. And also, you'll see in Marco Session in particular, the data access stuff is killer. He does some master detail relationships on the back end that magically are understood on the client. Oh. It's not really magic, but it feels like that. It's kind of the Delphi magic that when you always go, wow, how'd they do that? Come to Marco Session. I think that'll really help you understand how the framework on top of it is really where the value is. Uh-huh. And then the additional services around analytics and those kinds of things are really where the big difference is compared to some of the other technologies out there.
There's some question here about licensing prices. Mm-hmm. Is that available someplace people can find that?
We do have some published on the pricing website. Basically, it's a tiered structure. So you can buy in at, for example, up to 50 users. So that's like the lowest tier. And each of those users so you buy that package for $49.95. And then each additional user you can get for $100 a user. When you go to a 100-user package, then the price on the per user goes down. But really, what we want to do is be able to work with your capacity needs. So that I really recommend just calling a salesperson to talk through the pricing and understand how it fits your capacity needs more than just looking at standard tiered pricing.
Does EMS use for its low-level IP connectivity? Or what is it? How does it connect to the IP? What is the low level?
Right now we use some new technologies that we built around HTTP, but we do use Indy also, Indy sockets. We're doing more to go more standard HTTP also, but today's implementation utilizes Indy primarily.
Well, the SAPI module doesn't use Indy though, does it, or does it?
It does.
It does still use Indy?
Mm-hmm.
Okay, but it's able to run at a different operating level because it's a SAPI module?
Yep.
Okay. So yeah, ask Marco. That's a good answer. That's my answer to all questions. Okay. I know EMS is per user decreases in cost with larger installations, but is there any upper limit?
No, there's no upper limit. Again, we presented some tiers that match what we've heard are pretty standard tiers. The pricing actually gets reduced pretty dramatically as you move up in the tiers. I think our highest tier right now is at 5,000 users. Anything above that, you certainly is a negotiable price depending on your capacity needs.
Can a module be replaced without shutting down the entire server?
Yes.
Okay.
There's ways to restart each module. It's very quick.
Good. Is the back-end components Windows only?
Today, yes. And it's IIS only today. On the roadmap, we are working on Apache modules as well. And we've also shared that we are working on a Linux server implementation as well.
What about templating engines for EMS, like Razor is for .NET, to publish data via HTML, jQuery Mobile, etc., so we don't need to use EMS client components?
That's a really good idea. We don't really have anything built today like that, although, again, it's standard REST, so these templating components actually could work against it using, ASP. Or I should say .NET or any other language, JavaScript that you want to use on the front end. So it doesn't require using our components, doesn't require using our language really on the client side.
Yeah.
Because it's standard REST. You're going to get a lot more benefit from doing that, particularly when you're working with data But that was a big reason why we went with standard REST, was to make it available to other implementations that people may need to support out there.
Is there implementation inside of EMS working with data from databases, viewing, editing, synchronizing, etc., over REST, especially synchronization?
Yes, go to Marco's session. I think you'll be very pleased with what we've delivered.
Yeah, I haven't played with EMS much yet, but what I've found, it's been really a lot of fun to work with. Supposing in the future many Linux servers were used in parallel, will the cost still be tied only to the number of users and not to the number of servers?
Correct. Yeah, again, this is meant to use load balancing infrastructure that you may already have in place with your Apache servers or since you said Linux, and it's tied to the number of users, not the number of instances of the server.
Excellent. Okay, I think we're gotten through. Hopefully, I got all these questions here. Yeah, there's lots of other tools out there, but we feel like this is a really good, unique offering and has lots of advantages to some other tools that are out there.
Yeah, the main thing that you'll find is if you need to get something like this up and running, this is going to be one of the quickest ways you can do it, because you have everything you need to get these primary and critical services up and running. You can certainly build these types of services with other technologies, even DataSnap, but it's a huge time savings just to have them ready to go. So that's when you should consider EMS. And especially if you're in the enterprise and you're dealing with users, this is particularly targeted at your problem domain.
Do you promise to keep DataSnap alive along with EMS? That's probably the million-dollar question.
We are absolutely committed to maintaining and continuing to add features, platform support, for example, to DataSnap, yes.
And they serve two different purposes. It's not, one doesn't replace the other.
Correct.